Right. So we will start with a discussion of some of the questions from the test paper. So I'm putting up the test paper now for you. And over here, right? So you should be getting it on your whiteboard, all of you. So let's take a quick review of these questions. So the first one, as you can see, it's still have some people joining. Probably some people having some connection issues today, but anyway, as I told you, the lecture will be recorded, so it will be fine. And of course, any doubts in between, you can message me. Okay, so that right. So let's start by the review of the first question. So you can see that this one, a particle moves along a straight line, accelerates uniformly from a speed of 10 to 50 in an interval of 8 seconds. Then find the magnitude of its displacement during the interval of 8 seconds. Okay. So just take a quick look at this question and try to work out what would be the correct answer. If you've already done that, that's fine. So I'll tell you the answer in a moment, and I'll tell you a nice shortcut method also. So what should be the answer for the first question, people? Can you message me and tell me what is the answer you would have got for the first question? So let's understand the first question. I'm still waiting for your answers, people. Yes, Dhruv, that is correct. Very good. Starting with this. Right. So question one, it said that the initial velocity is 10 meters per second, and it accelerates uniformly to a velocity of 50 meters per second in 8 seconds. So 8 seconds. This is given to us. So from this, we have to find the displacement. Yes, correct. 240 meters, or D is the correct. Yes. So in 8 seconds, we have to find out. Now what? Yes. So Aparna, Tejas, Dhruv, all of you got the correct answer. Good. So what most of you, I guess, would have done in this is that you would have used the data that V is equal to U plus AT first. And from this, you would have figured out that 50 is equal to 10 plus 8E. So the acceleration is becoming 40 by 8. So 5 meters per second. And then you would have used the relation that V square is equal to U square plus 2AS. In this, you would have substituted 50 squared is equal to 10 squared plus 2 into 5 into S. So from this, you would have got the displacement as 2500 minus 100 divided by 10. Then you go to 240 meters. Everything we've taken in SI unit. So fine, this is a correct method. There's nothing wrong with it. But there are a couple of more things you can do, okay, which can make the question easier. Always typically graph for displacement makes it easier. So you can also visualize this as a graph. If you were to look at the velocity time graph, you would understand here that the velocity time graph would be a straight line because the acceleration is uniform, and it would be like this. The velocity is going from a value of 10 initially at t equal to 0 to a value of 50 at the time of 8 seconds. This is in seconds, this is in meters per second. So this way you can bypass calculating the acceleration and all that. You can see that this would be the displacement. So the displacement would be half into sum of parallel sides, that is 10 plus 50, into perpendicular distance between them, that is this, 8 seconds. So directly you can see you get an answer of 240 meters. This is another way we can do the question. And yet another shortcut I'll show you for doing the same question is you can also use the concept of average velocity. and the fact that displacement is average velocity multiplied by time. So here what is happening? Now the most important thing about average velocity is when acceleration is uniform, then we can write the average velocity and the average velocity simply becomes u plus v by 2. We can make use of this concept along with this one. So here you can see that from 0 to 8 seconds, that time interval, the average velocity will be u plus v by 2, so 10 plus v by 2. So that will be 30 meters per second. So naturally the displacement will be average velocity multiplied by the time for which that average velocity is. That is 240 meters. Now again, this might seem that okay, there are two equations that are solved, but you know, at least I've not done any intermediate solving like find out the acceleration and then substitute that in the square equation. I've done it. So even becomes an advantageous method compared to the just using the first two equations like we did in that part. Okay. So anyway, these are just a couple of alternate methods. It's not that you have to do by this method or you have to do by second method or first method. You will always have a variety of methods that you can rely on. I'm just trying to give you some options whereby you can see that in certain ways you can save time. Okay, so now let's go back to the paper. Now this is a very similar question to one I had given in the worksheet. Okay, and I had just briefly discussed with you in the worksheet. So now we can work this out. So what is the answer you're getting in the second one? The braking time is 0.4 seconds and the speed is 54 kilometers per hour, and from there it brakes at the rate of, or it decelerates at the rate of 5 meters per second. So what is the answer you people got for this? So I'm waiting for your messages. Technical error, is it? With IIT, Yuvraj, is this related to the lecture right now? If it is regarding something else like the website of IIT Kanpur or something, I would request you to please, the website, okay. Right, so Yuvraj, can you just contact me after the lecture about this? I will help you out. Okay? So this technical problem you are having with the website or any such issue that you have, if you can just, yeah, but now you're getting the answers E, that's correct. It's either E or C, I don't remember. I have to just work it out and tell you. By the way, I have the answer E here. Check it out. No, the answer is C actually. 2's answer should be 28.5 meters. Now I'll tell you why. Yeah, now coming back to your query, Yuvraj, the problem that you are having with the website and all, I'll help you out. I'll just, if you can, after this lecture is over, you can just message me on WhatsApp, okay, what error you are having, or if you can just send me the link of the page, whichever page you're opening and some error is happening, I will get it sorted out. Or you can even call me. Immediately after today's lecture, you can do around 5:30 or so. Okay, so let's take a look at this question. So what it is saying is that the vehicle is initially going at a constant speed of 54 kilometers per hour. First of all, let's convert that because everything else is missing. So that is 54 into 5 by 18. So that is 15 meters per second. That is the velocity with which it is. Now what happens is that it has a reaction time delta t of, I think it is 0.4 seconds, and deceleration rate 5 meters per second. So this is the data of the question. Just no, Yuvraj, no problem. You can. Interruption is not a problem. I'm just telling you that in the right now I won't be able to sort out, and after the lecture I'll sort it out. Okay, so yeah, this is the data. Okay, now we have to find out how much is the displacement from the time he feels the need to brake. Okay, so the total displacement will be, you can say, displacement during the reaction time plus the displacement during the actual braking when he starts decelerating. You can do it this way. You can break the motion into two parts. So this first part, it will be the uniform velocity into the reaction time. So that will become 15 into 0.4, that is 6 meters. And this you can use this, that the final velocity is 0, the initial velocity is 15 meters per second, and the rate of deceleration with the minus sign is minus 5 meters per second. So the displacement will be equal to this thing, v square minus u square by 2a. So final v is 0, initial u is 15, and the rate of deceleration is 5. So it comes with a minus sign. So as you can see, this becomes 225 divided by minus signs cancel out, divided by 10. So this becomes 22.5 meters. So that is why your correct answer finally is not 22.5. The correct answer is the total displacement from the time he feels the need to brake. So the reaction time is included. So that's why it becomes 28.5. So this is the formula based approach. But as you people know, I generally don't like formula based solving. I like to do it more by logic and by graphs and things like that. So I would also urge you, after you note this down and understand why it's 28.5, see how you can simplify the solution by using a graphical approach. Try to see if you can draw the velocity time graph for this. So alternately, you make the velocity time graph yourself and see from that graph what you get for the solution. You will see that it will be less time taking than this. Right, so most of you must have got this by now, that look at the velocity time graph here. Just draw the positive axis because he's not going backwards. He's only decelerating and coming to 0. Yes, I'll show the perspective. So here, what is happening is the velocity is constant for a bit of time. That's his reaction time. And then he starts decelerating at the uniform rate. So he comes to this. So this time here is 0.4 seconds. And this is what he's starting with, 15 meters per second. But during this next phase, he has a deceleration. He has a deceleration of 5 meters per second. So you can see that from here to here, how much time he will take. The time taken to decelerate, you can see the time for deceleration. That will be the change in velocity upon acceleration. So the change in velocity is, the velocity is reducing by 15 meters per second, going from 15 to 0. And the rate of deceleration is 5. So this is 3 seconds. So this time here will actually become 3.4 seconds. Because this interval of time from here to here is 3 seconds. Whereas this interval of time was 0.4 seconds. So this is his delta t for reaction time, and this is his delta t for the actual breaking time. This is breaking. Whereas delta t for the reaction time, that is 0.4. Those are these two things. So now what is the total displacement? Is this total area? So this area will represent the displacement, which is what we have worked out in the first method. I'm just showing you both the methods. I'm starting with this. Okay, then I'll bring you back to the graph. So this is the data of the question. That his reaction time was this much, and his rate of deceleration was this much. So, and the initial velocity was this much. Going at a constant velocity of 54 kilometers per hour. So from this, we have to find out the total displacement from the time he felt the need to brake. That is, his brain saw the message that yeah, I have to brake, but then it takes some time for that message to convert into a reaction and actually push the pedal of the brake. So that is what we call the reaction time. Okay, so that reaction time was 0.4 seconds, and then of course the actual braking started. So we have to find the total displacement, which is the sum of the displacement during the reaction time plus during the actual time when his foot was on the brake. Okay, so one is the formula based method, which I've just shown you here, and next I will just below take you to the graph method, which is in my opinion the easier method of solving this problem. But that's a matter of opinion, okay, because it's just probably it takes the same amount of time to solve by both the methods. Right, so I'm just bringing you to the graph method now. Okay, people, so hope this is clear. So these were, I would say, comparatively two easy questions because they were more or less based on the worksheet which we had discussed last time also. Now let's come to the ones which many of you asked me over the week also, and I told you I'll solve in the class today. So that is question 3 to 6, which refers to this graph. So first I would suggest just read through the questions once more, and let's understand all the points carefully about the question. I'm just minimizing a little so that we can see the whole question. So 3 to 6, this is the graph, and these are the questions. Right, so what you can see in the graph is pretty simple. Third answer is B, that is correct. And Bhageshi, third answer is B, so yeah. Aparna and Bhageshi, both of your third answer is correct, and yes. Right, so let's understand. So first of all, let's see what information the graph is giving us. Is there some symmetry to it and all that? Let's understand. So as the graph is showing you, you are starting from rest because your V is 0 at t equal to 0. The graph is starting from the origin. And you are accelerating from 0 to 20 meters per second with a rate of acceleration a1, which is 4 meters per second. So though that time is not given to you, yes, Yuvraj, your answer is correct. Okay, so though the time in between is not given to you, but you can calculate that because you know that you're going from 0 to 20 in a using an acceleration of 4 meters per second. So you can see that that will be 5 seconds because V is equal to u plus 80, so 20 should be equal to a1 into that time. So the time in between where it reaches the peak value of velocity, that should be 5 seconds. Now the next thing you can see that once you reach 20 meters per second, you're just there for just an instant because you immediately start decelerating at the rate of 4 meters per second. And because your rate of acceleration is equal to the rate of deceleration, so we just saw that it took 5 seconds to reach 20 meters per second. So we know that it will take another 5 seconds to reach 0 again. So that is your T1. So that is why your T1 will become 5 plus 5, 10. Understanding the point. So that is the thing of T1. And that is how we'll get T1 as 10 seconds. Okay. We'll just use the fact that V is equal to U plus AT for the first part, where E1 is plus 4. And then again V is equal to U plus AT for the second part, but there is a deceleration from 20 to 0, and the rate of deceleration is 4. So again, that will give us that time, and we'll add the two times, and that will be 5 plus 5, and that comes out to 10 seconds, which is T1. Okay. Now the very interesting thing, we have to find the time T2. Okay. Given that it returns to its starting point at T2. So what is happening after T1? No, the particle continues with an acceleration of minus 4 meters per second. So what that is telling me is that the velocity went from 20 to 0 at time T1, and then he continues with a negative acceleration. That means what happens now, his velocity has become negative. So his direction switches. His direction of motion is switching from the positive side to the negative side at which instant of time? Precisely at T1, which is 10 seconds. So 10 seconds के बाद क्या हो रहा है? His displacement is actually backwards. Up to 10 seconds, he was moving forward, albeit with variable speed. First, the speed was increasing, then his speed was decreasing. But after 10 seconds, he now starts coming back. And as he's coming back, he's again accelerating till his speed becomes how much? 10, or his velocity becomes minus 10. But then suddenly his acceleration becomes 0. So he continues at 10 meters per second, but with a negative direction. And given that, the question is telling us that at the time T2, he actually reaches where he started. That means what should his net displacement become? It should become 0. Okay. So let's first analyze this question in terms of what it would look like on a one-dimensional line as the motion is happening. So let's first analyze that, and then we'll come to this. Okay, so in terms of the graph, you can see that your velocity time graph is such that you're going from 0 to 20, then coming from 20 to, interestingly, but what is now specifically given is that the value of this velocity is minus 10, and the value of this peak velocity is plus 20. And here the rate of acceleration is plus 4 meters per second square. Whereas in this part, the rate of deceleration is minus 4 meters per second. So as I told you, first we can concentrate on up to T1 what is happening. So up to T1, as let's say some T0. Okay. What I can do is I can understand from 0 to T0 what is happening. Your acceleration is plus 4. Your initial velocity is 0, and your final velocity is plus 20. So using this data and using the fact that V is equal to U plus AT, you will get that time interval, which is T0 seconds, as 5 seconds. That's the first. Then you come to the next interval, which is T0 to T1. So during this interval, what is the time actually? The time is actually T1 minus T0. That is the actual value of time. And in that time, what is happening? You are changing from an initial velocity of plus 20 to a final velocity of 0 using a deceleration which is minus 5 or 5 meters per second square in magnitude. So this is what is happening corresponding to the second part of the graph. You can understand. So this is what is happening between this time T0 and this time T1 when the velocity is decreasing from plus 20 to 0. And when it's 0, momentarily it's at rest. So here you can see again, if you use the relation, V is equal to U plus A, which is minus 4 into that time T. So that time comes out to be 5 seconds again. So that means again what is happening? T1 minus T0 is equal to 5 seconds. That interval of time is 5 seconds, and this interval of time is also 5 seconds. So combining this and this, now what we are getting as T1. T1 is 10 seconds. Okay. So this was our this part. This was our third one. Now let's come to the next part. So what we have to understand for the next part, I am going to go back to the graph and annotate. Okay. So in the next part, what is happening at T2? Okay, the net displacement is 0. Okay. So for that, what we have to do is to understand how the net displacement is becoming 0. We have to actually calculate this time. This time is T3. Okay, and then understand that this whole area plus the algebraic sum, which will be with negative sign of this whole area, this should be how much? The net area will be 0. That is where this question is a little bit complicated. Also, if I convert this into an x-axis type of motion, you will understand. Suppose the motion is along the x-axis. So let's say this is a person. He's starting at rest at t equal to 0. Then what is happening? He is moving with a uniform acceleration a1 of 4 meters per second square till he reaches how much time? He reaches a time of that t0 which we have calculated of 5 seconds. When what happens is his velocity becomes plus 20 meters. Okay. Now thereafter what happens? The second part of his motion starts. So I am showing the second part with a different color. The second part of his motion is actually decelerated. So he has an acceleration of minus 4 meters per second. So his velocity starts to decrease now. Okay? And as it starts to decrease, at the time T1, which is we just saw 10 seconds, momentarily what is happening is velocity is becoming 0. Okay. So you can see here to here, the motion is the accelerated motion. Then here to here, the motion is the decelerated motion. Okay. So that is covering this part of the graph. Up to T1, accelerated motion, then decelerated motion. After that, what is happening is velocity is becoming negative and is increasing from 0 to minus 10 for some time. Okay. So after this point of time, it was 10 seconds, T1 equal to 10 seconds. Now what happens is his velocity now becomes negative after, and this becomes 0. So it remains minus 4 meters per second square till he reaches some time here where his velocity becomes minus 10 meters per second. With sign it becomes minus 10 meters. So this he reaches at some time T3, let's say, which I want to calculate. And that time in my graph is this one, T3 over. Okay. And after T3, what happens? It's like the fourth part of his motion starts, which is with uniform velocity. The fourth part of his motion is with this uniform velocity of minus 10 meters per second because his acceleration is 0. And this continues all the way till what happens? Till he reaches where he started. So he reaches, so just if you superimpose these two diagrams, it's actually happening along the same straight line. He's going up to here, then he's having a decelerated motion, then he's coming backwards but with an acceleration, and then finally the last part of the motion is coming with constant velocity. When this is acceleration is 0. And he comes back to where he started at time t2, which is what we have to calculate. Okay, so the second part of his motion, or you can say the first part was accelerated, second part is decelerated. Now the next part is what is happening. His acceleration is minus 4. Okay, but during this part, what is happening is he's having uniform acceleration of minus 4 meters per second square. Okay, and negative displacement. His displacement is negative because his velocity is also in the negative direction. And then final part of his motion, what is happening from the time he reaches the velocity of -10, he returns here with that velocity of -10 meters per second. He returns here, but at the time t2, which we have to calculate. So during this part, this last part of the motion, what is happening? He's coming back with uniform velocity and therefore no acceleration of v equal to -10. This part is velocity is increasing in magnitude coming back, increasing from 0 to -10. So the magnitude is increasing from 0 to 10. And this part, the magnitude of his velocity is remaining constant, 10 meters per second, and his direction is backward till he reaches where he started, and that time is. So first of all, just go through this one and tell me if this concept is clear with respect to the graph amount. So unfortunately, I can't show it in the same screen, so I'm just showing you the graph separately once. And I will come back to this. Yeah, to answer your question, Atharva, we can use the slope concept for the time t1. So we can use the fact that, but for that we have to know t0. That is the thing. So t0 has to be calculated, and once t0 is calculated, you can calculate t1 by slope or v equal to u plus at or whatever method. So the motion is, you can say, in 4 parts. The first part is he's accelerating along the positive x-axis. Then the second part is decelerating along the positive x-axis till he comes to rest momentarily. Then the third part is he's now coming back, okay, but with acceleration. So his speed is increasing, but he's coming back. And the final and the fourth part is where his speed is constant, but he continues to come back at the speed of 10 meters per second till he comes back to where he started from, till he's back to his starting position. So his net displacement is 0, and that time is t. Okay, so hope people this is clear to all of you. Okay, so now next what I want you to do here is, first of all, I want you to calculate that time t3. Okay, so the first thing you do next is find the time t3, which is not given in the question, but I have labeled separately. That is the instant when his velocity becomes -10 meters per second for the first time. Okay. After that, it continues at the uniform velocity, but it becomes -10 meters per second for the first time at that instant. You find that t3, and then find the displacement in these 3 parts. Find the displacement from 0 to t0 or 0 to 5 seconds. Then from t0 to t1, that is from 5 to 10 seconds. And then also find the displacement from t1 to the time t3 that I mentioned, okay, or 5, sorry, or 10 to whatever t3 you would have calculated in the first part. Okay. So 10 to t3, you calculate these, how much these are, okay, and then apply the condition that net displacement, okay, which is from 0 to t2, this has to be how much. So that is how we'll get the final unknown quantity. Okay. So I'm just leaving you with this diagram, and hopefully you already have the graph in the paper also. Okay. And I just want you to calculate these things. Find out T3 and the displacements from 0 to 5 seconds, 5 to 10 seconds, and then from 10 to whatever that T3 is. Yes, very good. Alina, that's the correct answer. T3 will be what you have got. Just waiting for the others to also confirm, but your answer is correct for T3. Yes, Yuvraj, your two answers are correct. Bhagyashree, your answer is correct in terms of the interval of time, but you have to tell the total time. Na? T3 is the value of time from t equal to 0. What you're giving me is the time interval between between T1 and T3. Okay. All right, so let's just come back to the graph, and from here, let's understand how we get T. So we have now already got that T1 is 10 seconds and T0 is 5 seconds. Now we want to find out how much T3 is. So for that, you look at this line's slope. The slope is how much? It is the rate of acceleration, which is -4. So that slope should be equal to y2 minus y1. So at this point of time, so now you use this data point and this data point. So look at the slope between these 2 points, or you can even look between this and this. Doesn't matter. Okay, so I am looking at the slope between these 2 points. So the final velocity is how much? -10 minus the initial velocity is how much? 0. Divided by the time interval, which is T3 minus T1. Okay. So this is what we should get. So I'm just removing this part for the moment. That we can use this realistic. Okay. So there you go. So now you can see that -4 is equal to -10 divided by T3 minus 10. So that small interval of time T3 minus T2 is actually 10 by 4. T3 minus 10 or T3 minus T1, that small interval of time is 10 by 4 or 2.5 seconds. That's very simple. That how much time it takes a velocity to go from 0 to -10 when your rate of acceleration is -4, which is -10 divided by -2.5 seconds. Okay? So that's how your time T3 is actually becoming 12.5 seconds. So this time T3 is becoming 12.5 seconds. So now I know all these 3 times. I know this is 5 seconds. I know this is 10 seconds. And I know this time here is 12.5 seconds. This is still unknown. Okay. But next what I'll do is I'll calculate the total area up to here. And then I have to add the area further here and make that net 0. Okay. So further I can see that now displacement from 0 to 10 seconds. I can do that directly, or I can write that as displacement from 0 to 5 plus displacement from 5 to 10. Doesn't matter. I can do this directly only. That will be the area of that triangle on top, which will be positive. So the base of that was 10 seconds and the height was 20 meters per second. Okay. So that is becoming 100 meters. Or if we individually calculate these two, they'll come 50 and 50. So that is the displacement from 0 to 10 seconds. Now I have used the area of the triangle method. So I'm taking you back to the graph to understand this. I'm just calculating this area, the area from 0 to 10 seconds. So it's half base into height. Okay. Then next what I'll do is I'll calculate the area of this small triangle here, this one, from 10 to 12.5. So that triangle has a base of 2.5 seconds and a height of 10 seconds, but with a 10 meters per second, but with a negative sign. That means it's having a negative area or it's creating a negative displacement. So next I'll see the displacement from 10 to 12.5 seconds. That is negative of the area of that triangle. And the area of this triangle was this one. So that is minus of 12.5 meters. I hope this is clear. So that small triangle over here, this one, this triangle, this one's area. So this time interval from here to here is 10 to 12.5. So the base is 2.5 seconds. This time interval from here to here is 2.5 seconds, and the height is this 10, but with a minus sign. So the area comes with a minus sign, and that area comes out to this one. Okay. Now, finally, what should happen? We don't know our T2, but in terms of T2, what is our displacement from 12.5 to T2 seconds? It is equal to minus of 10 meters per second multiplied by the time interval, whatever the time interval is. So that time interval is here, nothing but T2 minus 12. So that's this. So this is this, this is this. Now, what should be a net displacement? Should be 0. That means displacement from 0 to T2, that net displacement should be 0. That means displacement from 0 to 10 plus 10 to 12.5 plus 12.5 to T2. The sum of these should be 0. The algebraic sum of these should be 0. So this we had already seen was plus 100. The second small triangle was minus of 12.5. And the third triangle was basically equal to minus 10 delta t, where delta t was that time interval from 12.5 to t. So this should be 0. So this tells us how much time it is. You'll see that that time interval delta t will come out to be 100 minus 82 minus 12.5, that is 87.5 divided by 10. It comes out to be 8.75 seconds. So that is that time interval. Now what is this time interval? This time interval is from 12.5 seconds to t. So that means t2 should be equal to 12.5 seconds plus this time. So substitute that here. As you can see, you will get 21.25 seconds. That should be okay. Let me just verify that too. So get this. So it should be C, question 4. So I'm just going to minimize this a little bit for you, but the groundwork for this we've already done when we calculated these areas. Yeah, it should be. Don't worry. Alright, so back in terms of the graph, what we're doing is we're seeing the area of this upper triangle, which is the displacement from 0 to 10. That was plus 100 meters. Then the area of this tiny little triangle here between 10 and 12.5, that area with the proper sign was actually minus 12.5. So from 0 to 12.5, कितना displacement हो गया? It is 100 minus 12.5 or 87.5. So then from that 12.5 right up to T2, he has to come back a further displacement of how much? He has to come back a further displacement of 87.5. That's why that last area should be minus 87.5. Okay. So basically what is happening here is you can see that in this diagram from here, just follow my cursor, from the initial time to 10 seconds, okay, where his velocity becomes 0. He has actually traveled 100 meters. Okay, this one is 100 meters. Then by the time his velocity becomes minus 10, which is over here below, the time is actually 12.5. And the displacement is actually how much? The displacement is now 12.5 backwards. Okay. So 100 minus 12.5, the displacement is actually this much. What we call 87.5 from here. So from here, he has to come back further by how much? By 87.5. So it's further displacement from T3 right up to here. That displacement is how much? That displacement is our minus 87.5 with the proper sign, and that's happening at a constant velocity of 10 meters per second, minus 10 meters per second. So that time taken is that much time, 8.75. So when does he reach here? At the time T2, which is finally coming out to be 0 plus 10 seconds plus another 2.5 plus another 8.7. So 12.5 plus 8.75, that is the total time. That's 21.2. Okay, so let's go back to the question paper and understand what else has been asked here. So this is done, third is done, fourth is done. Okay, now next we have to look at the 0 to 5 seconds. So that's also done. This will be 50 meters. Okay. This one is this. And total distance traveled. Now total distance traveled कितना हो जाएगा? This displacement is 0. But what about the total distance traveled? It will be the magnitude of this area plus the magnitude of the lower area. So this area was how much? It was 100 meters. And then he was coming back 12.5 and then coming back further 87.5. But as far as distance is concerned, he has gone 100 meters forward, then come back 100 meters to where he started. So the total distance traveled is how much? It's going to be 200 meters. So E and D should be the answer of 5 and 6. E and B are the answers of 5. You can note down these answers. I'll send you the answer. So these are the answers. So that is that set of questions. Just give you question again for a moment. All right, people. So hope this is all clear. Okay. Next up, let's move on to the next question. So 3, 4, 5, 6 is done. So particle is moving eastwards with a uniform velocity of 5 meters per second. And in 30 seconds, its velocity changes to 5 meters per second northwards. from east it changes to northwards. Okay. For 40 seconds. Then you have to find the net displacement in the 70 seconds. He has gone for 30 seconds towards east at a speed of 5 meters per second. Then for the next 40 seconds, he has gone northward at a speed of 5 meters per second. And now you have to find the net displacement. So this is a very simple geometry based problem. You just draw the diagram and understand how his displacement is happening. He's first going towards the east to how much displacement? 5 into 30. So 150 meters towards the east. Then he goes north at 5 meters per second for 40 seconds. So he goes how much? He goes 200 meters north. So your net displacement is actually the sum of a displacement of 150 meters east and then this thing 200 meters north. Okay, so what should be your answer then? Yes, that's correct. 250 will be your answer. You know, he's going like this first. He's going eastwards to a distance of 150 meters. Towards east. And then he changes direction and he goes northwards. He goes towards north, but to a displacement of 200 meters. Because he's going at 5 meters per second for 40 seconds. That's 200 meters. So now in this diagram, you can see what is his net displacement. The net displacement is from where he started to where he ended. So this is his net displacement. This is his net. All are of course straight lines. So you can see that the net will become 250. Because this happens to be a right angle. Okay, so that is why your answer here will be. All right, now let's move on to the next one. 8th question. A particle travels E to M along a straight line with a uniform velocity of 8 meters per second, and then back from M to A with a uniform velocity of 2 meters per second. Then the average speed is how much? Remember, here I have not asked you about average velocity. I have asked you about average speed. So the formula you will here use for average speed over here, that formula can be this. So V average. So V average is equal to distance upon time. So just use this concept. See if you can work out. Total distance upon total time. So total distance is pretty obvious. How much is the total distance he's covering? He's covering a distance of, he's going, A to M. So just calculate the distance A to M first and then back from M to A. So double of the distance AM. So the total distance is double of the distance AM. So just try to use this concept to solve this. But remember, here we are talking about average speed. You're getting the answer C. Yeah, C is correct. Correct. 3.2 is the correct answer. Anna, that's correct. Okay, so should be fairly simple. Let's just cross verify it. So how we'll do this now? See, nothing is given about the distance am or the amount of time. So we have to make some kind of an assumption. Okay, and whatever assumption we make, we should be able to eliminate that quantity so that we get our answer independent of it. Okay. So it's very simple. If I just assume the distance from A to M, assume the distance from A to M is some D. Okay. This distance is some D, let's say. So T equal to 0, he starts here. Okay. Going at a constant speed of 8 meters per second. So you will reach here at a time T equal to T1. So you can see that T1 will be D divided by 8. If D is in meters, so it will be in seconds. Okay. Then what is happening thereafter? He is turning back, and now he is coming backwards with a speed of 2 meters per second. So now here the total time is, let's say, T1 plus T2, where T2 is the amount of time taken to come from here to here. So that time T2 is the same distance D is traveled, but with a speed of 2 meters per second. So it's so much. Okay. So now his average speed will be equal to total distance upon total time. So the total distance is becoming D plus D 2D, and the total time is T1, which is D by 8, plus T2, which is D by 2. So that becomes 1 upon 1 plus 4 divided by 8. Sorry, 2 upon. So 16 by 5. 3.2 meters per second. This is the average speed. Okay. But you should be also mindful of one thing, that the average velocity will be 0. Why? Because the net displacement is 0. So just minimizing this for you people. So again, this is one of the fairly easy questions, provided you have read the question correctly and not made a mistake between average velocity and average speed. So sometimes in an exam situation, if you are in a hurry, you might confuse the two things and make a mistake like that. But if the interpretation of the question is correct, then I don't think this should be a very difficult type of problem. Okay, fine. Now let's move on to the last two questions. So this question also has to be kind of solved in a similar kind of manner. 1/3 of the distance he travels at 30 kilometers per hour, the next 1/3 at 40, and the last 1/3 at 24. So find the average speed. So just assume the total distance is D or 3D or something, and calculate the time taken for the first 1/3, the second one, the last 1/3. and divide the total distance divided by the total time, and you'll get the answer. So just try to get the correct answer. It's already there in the key below. And then we'll discuss the 10th question. Now 10th is a little more interesting. It's an unusual type of question with a bit of 3D geometry, but we'll understand it. The result of the test beta you'll get very soon. Sometime within the next couple of days you'll get the result. Okay, so what is the answer you got for this? Are you people getting this 30 last part? So he's doing 1/3 at 30, 1/3 at 40, and 1/3 at 24. So let's see how that works out. So the total distance is D. D. Then D by 3, he's traveling at 30 kilometers per hour. Okay, so just let's assume this is in kilometers. So that time T1 that he takes for that first part of the journey will be D by 3 divided by 30 in hours. Similarly, the second 1/3 distance he's traveling at 40 kilometers per hour. So that second time interval is again D by 3 but divided by 40. And the third time interval, again he's traveling D by 3 but at 24, I think it was, kilometers per hour. So that time is becoming the distance D by 3 divided by the speed, 24. All this is in hours. Okay. So now average speed is nothing but total distance divided by total time. That's all we have to do is this. So D divided by D by 3, if we take common, we have 1 by 30 plus 1 by 40 plus 1 by 24. Okay. So just take this 3 in the numerator, cancel off the D's, and here in the denominator we can take 240 as an LCM, for example. Okay. So 8 plus 6 plus 1. So this becomes 3 into 240 divided by 15. Correct. So 240 by 5, or 480 by 10. So let me check. Yeah. my mistake. This should be 10. Right? So this should be 4. So that will become 30. So this should be our average speed. Yes. Okay, we can take 120 also as LCM. Yes. Right. So anyway, so hope this question is clear. Now this last one. So first of all, let's understand the geometry of this very clearly. Okay. So just go through the question. I will give you a hint about it. Okay. Yes, beta, that's correct. You got the right answer. Aparna, your answer is correct. So the thing you have to realize is that the 3 displacements which are given, 300 meters towards north, and then 400 meters towards west, and then vertical displacement of 1200. The relationship between the individual displacements, they are actually mutually perpendicular, because you know that the direction of north is perpendicular to the direction of west. But compared to that north, west, east, south, where does the vertical direction lie? It lies perpendicular to the whole plane. No? So this is where you have to understand that north, south, east, west is in a horizontal plane. When you place the compass needle on the ground, it points in that north south direction, but that is in which plane? That's in the horizontal plane. East west is also lying in the horizontal plane, whereas the vertical direction is the direction against gravity, so it is perpendicular to the ground. It's perpendicular to the horizontal plane. So that is why the third displacement, which is a vertical height of 1200 meters, this one is actually perpendicular to both of these, this and this, and these two are perpendicular to each other. Yes, that's. So I will solve this problem without getting into any 3D geometry or anything. Okay, we will just solve this problem by using normal Pythagoras theorem kind of geometry. Though at a later stage we can solve this using 3-dimensional vectors. Okay. So the last question, what is happening here? So the thing you have to understand is that if this is your horizontal plane, let us say, I've just drawn it like this. To understand that if this is east and this is north, that's west and this is south. These are all mutually perpendicular. So this, in this diagram, this is like my horizontal plane. This is the plane of the ground. Just visualize the floor on which you are sitting or standing or whatever. This is that horizontal plane. So compared to this, where will my vertical axis be? My vertical axis will be perpendicular. Okay. So my vertical axis now will be like this. This is perpendicular to this whole plane. It's perpendicular to each of these axes. This is the vertical direction. So this is the direction in which gravity is acting. If this is the floor, the north, south, east, west plane, that is the floor. Okay. So now you understand what is happening is that in this diagram's context, what's happening is first making a displacement of 300 meters towards north, then 400 meters towards west. So he's going like this. He's going 300 meters towards north. Okay. Then he's making a displacement of 400 meters towards west. Okay. And from there now he's making a vertical displacement of 1200 meters. So going like this. Okay. Now this diagram, immediately when you look at it, it doesn't do justice to what the question is, because you have to understand these are perpendicular to each other. These two vectors, they are lying in this plane, and this third vector is perpendicular to this plane only, like this. So that is the idea. Okay, so this is 300 meters towards north. Okay. And then this is 400 meters towards west. And then this is 1200 meters vertically upwards. Now it's very difficult to understand how we can join these two to get a straight line here. So what we'll do first is that we know that we have to actually calculate what quantity, the net displacement. So the net displacement here is going to be this. Yes. Starting from here is reaching this. Okay. Just like this. You understand? It's a three-dimensional figure. This one is vertical, and so now what I'm going to do is I'm going to break this down into two simpler triangles. Okay. So for that, first of all, I'm going to label this diagram. Okay. So let's say where he started from, that point was E. Then after completing a displacement towards the north, he reached the point B. Then after completing the displacement towards the point, towards the west, he reached the point C, and then he went vertically upwards. Okay, so as you can see, EB is 300 meters towards north. Okay. Then BC is 400 meters towards west. And then finally CD is 1200 meters vertically upwards. So what we have to find now is ED. We have to find that ED. Okay. So I'll break it into two triangles first. First, what we'll do is we'll look directly into the horizontal plane at triangle ABC. Okay. So now I'm making a two-dimensional diagram. Okay. So I'm back to making a two-dimensional diagram where I understand that I'm looking straight into my horizontal ground or horizontal plane. So these are my north, south, east, west directions. And gravity is here going into the plane, or the vertical direction is coming out straight towards me perpendicularly. So this is that kind of diagram. So in this diagram, where is my displacement towards the north of 300 meters? It's like this. And where is my displacement towards the west of 400 meters? It's like this. Okay. So in this diagram, this is where I started from the point E. This is where I completed the displacement of 300 meters towards north. And this is where I completed 400 meters towards west. And reach the point C. So now next what I'll do is something very interesting. I'll also draw this line. So you can see that the line AC is equal to 500 meters, okay, because this is this. Okay. And more interestingly, AC lies in the horizontal plane Understand this? So AC lies in the horizontal plane. Okay. So this is the first step. So just take a moment to understand the relationship between this three-dimensional diagram, where you can understand you have gone on your towards north, then on your flow you turned left and went towards west, and then you suddenly vertically took off and went towards the ceiling through 1200 meters. Okay. Now this diagram I'm breaking up into smaller parts. So first I'm looking straight vertically down at the floor. So what I'm seeing this triangle ABC. So that triangle ABC is over here. Yes. So in this diagram now actually the vertical is coming out of C. It's coming out of C. So in this triangle, this side will become 500 meters. Okay. So hope this is clear. Now next what I will do is I will look at, so back in this diagram you can see that triangle AC, that side AC is over here, this one. So next I will look at the vertical plane of triangle ACD. Okay. So in this diagram you can understand that where is the point D lying? It's actually lying above C. It's lying towards you. If you're looking at the floor, so C is on the floor, A is on the floor, but the point D is directly above C at a height of 1200 meters above. So now imagine you're joining those 3 points, the point D which is above and these 2 points A and C which are on the ground, and you are now looking at that triangle. Okay. So we are looking at that triangle where this is on the horizontal ground. This point is E, this point is C. Okay. But this line is now vertical. This is now vertical line. And this is where my point D is. And though my diagram is not to scale, this is 1200 meters, so let's make it to scale. So it is much smaller. $500 meters here, something. So this is the vertical plane. So in this diagram, gravity is going down like this. But this is the vertical direction. Okay. And your north, south, east, west is somewhere in between because AC is. So now in this diagram, what is my net displacement? It is this side. This is the same line AD. So this is my net displacement. This is the line AD. It's the same line that we saw in the first diagram, which was a three-dimensional diagram. This one. Okay. But now in this diagram, actually, what we are doing is we are now, I just magnify this a little bit. Okay. Now in this diagram, what we are doing now is we're looking at this triangle. Join the points E and C. So C was this point over here. So now you look at the whole triangle. So you see this triangle ACD. This one, this triangle ACD. So in this triangle ACD, this AC is actually lying on the ground and CD is vertical. So this angle is 90 degrees between CD and AC. And we are trying to find out what? AD. That is the net displacement. This is what we are trying to find. So this triangle only I have drawn, but in that triangle I found out first AC. So AC kaise mila? By drawing the triangle ABC, looking into the ground. So I got AC is 500 meters. And then I next look at that triangle ACD as a vertical triangle. I look at it from the side. So when I look at it from the side as a vertical triangle, it becomes like this. Okay. So the height of the triangle is 1200 and the base is actually AC. So what about the net displacement? It is square root of 1200 square plus 500 square. So you can take 100 common and we are left with 12 square plus 5 square, which you know becomes 13 square. So it becomes 1300. So that is my net displacement. So later when we come to things like three-dimensional vectors and all this, you'll see this kind of analysis helps us a lot. Okay? By visualizing these kind of, you can say geometrical IQ type of problems. Okay, this is not really a vectors problem. I have not solved it using vectors. I've just solved it using just visualization of three-dimensional geometry. But that this whole exercise of doing visualization of three-dimensional geometry will help us a lot when we actually come to vectors in 3 dimensions and all that few months down the line. Okay, people. So hope this is clear. So this was about your paper discussion. Okay. I will be giving you the worksheet along with the solutions also this time. So this whiteboard notes I'll be giving you. Last time, unfortunately, my whiteboard notes, the software had got corrupted, so I could not. I'll still have to put some effort. I'll be able to salvage it, but I haven't managed yet. Today, hopefully, that will not happen. You'll get the whiteboard notes. So you'll have the solutions of these things. Okay, so that was about the paper discussion. So I'll just quickly refresh the screen once. All right, so now what we're going to do next is we're going to continue ahead with kinematics. And today, how to apply motion along a straight line with uniform acceleration. How to apply that concept in this thing, vertical motion. Okay, so we were discussing last time about these formulae. Now we'll see how to apply them. So we're seeing uniformly accelerated motion along a straight line. We were looking at that earlier. Uniform acceleration. So as an application of that today, so we saw all these formulae related to it. Okay, we saw that V is equal to U plus AT, S is equal to UT plus half AT square. V square is equal to U square plus 2AS. These are the standard ones. And we saw some couple of other ones also, that average velocity is equal to U plus V by 2. And that displacement can also be written as average velocity multiplied by time. Ninth question, beta, I did, no? Bhavik, ninth question I have done. So I think unfortunately at that you had got disconnected and you came back. So you'll get the recording of this. Don't worry. You'll be able to see the ninth question in the recording. Okay? Today evening I will send you the recording. Okay? So these were now as an application of this we will see. We will see vertical motion. Vertical motion under the influence of gravity. So as you know, near the surface of the earth, we take the acceleration due to gravity vector as a uniform magnitude quantity, which is 9.8 meters per second square, which we often take an approximate value of 10 meters per second square. So why we are able to take this as uniform? Because what is happening is near the surface of the earth, our typical height is very small compared to this thing of the earth itself. So I think there's a lag happening. I'll just give me a moment, guys. Okay. So why we are able to treat gravity as constant? Because G is uniform at the surface of the earth, okay, or at a height h such that that height is very small compared to the earth's radius. Okay. So RE is the radius of the earth. So you know that approximately that is 6,400 kilometers. So unless we are talking about a height of a few thousand kilometers, so it's significant compared to radius of the earth, we can treat G to be uniform. Okay? So G is uniform as long as h is very small compared to the radius of the earth. So h is a few meters, or h is even 1 kilometer, or even up to 10-15 kilometers. It's nothing compared to 6,400 kilometers. So G is uniform. Okay. Whereas yes, if you take an object to a height of let's say 3,000 kilometers, that's almost half the height of the radius of the earth, then there's a significant change in the value of G. And we will study that formula of how to calculate the change in the value of acceleration due to gravity also at a later stage when we study gravitation. But in these problems, we are assuming always that we are dealing with this kind of situation, that the height up to which we are making the body move or from which we are dropping the body, that is very small compared to the radius of the earth. Okay? So we are able to treat acceleration due to gravity as uniform. So having done that, once we understand that G is uniform, so we can look at the straight line motion or the vertical motion as an application of what we are discussing. So for example, from the ground level, if we project a body vertically upwards at a speed u, so this is vertical projection. So the direction in which we are given the initial velocity is perfectly upwards, it's vertically upwards at t equal to 0. Then as it moves up, we can track its motion and understand things like displacement, velocity, etc. as a function of time by just applying the equations of straight line motion with uniform velocity. So at some time t, if it's reached here, by then its velocity has become v. V might even become negative, because as you know it goes up and comes down. Its displacement has become some s. Okay. So we can find out these two things, the displacement from here to here and the velocity at this instant by using the equation of straight line motion. So here what we'll do is we'll take the upward direction as a positive y-axis. So that is our positive direction. Okay. The sign convention we are using is that we are taking the upward direction as positive. So with that in mind, we will write our initial velocity with what kind of sign? We'll write it as plus c. But we'll write our acceleration with what kind of sign? Negative. Okay. And we'll use the equation that v is equal to u minus gt. Okay. And we'll use the equation that s is equal to ut minus half gt square. Okay. So these become the first two equations. Just to answer some of your questions which I'm getting about screen resolution, make this large, make that small and all that. No, unfortunately I cannot keep adjusting to each one of your own needs like this. Okay. This is according to what resolution I require to be able to use the writing pen and all that. And I'm showing you the significant part of the screen that you need to concentrate on right now. Okay, so just work on this. Okay. You will be provided the video and the screen later, so you can go through it all. Just concentrate on what I'm doing over here. You don't need to see what's about this right now. You need to concentrate on what's happening over here. Okay. So when we project something vertically upward, because we are taking the upward direction as positive, so we'll write the vertical projection velocity as positive because it's a upward projection. So the initial velocity vector is pointing in which direction? The upward direction. Hence we are taking positive sign. But acceleration due to gravity is acting in which direction? Downward direction. So because it's acting downward, it has a downward acceleration due to gravity. The earth is pulling it down with mg force. So the acceleration is becoming mg divided by m, so that's g, but in which direction? Downwards. So hence it's coming with a minus sign. And then we are just using the formula v is equal to u plus at, and we are using the formula s is equal to ut plus half at. So from that we understand how the motion is. Okay. So let's look at an example of this next. So what we are doing in this example is, from the ground level, let's say a ball is thrown vertically upwards at time t equal to 0 with an initial velocity of, let us say, 60 meters per second. So a ball is thrown vertically up at 60 meters per second from the ground at t equal to 0. Okay. Take the value of g to be 10 meters per second. Okay. Now we want to find displacement the displacement, the distance traveled, and the velocity at, so all these three things I have to calculate at a certain time. So first I am calculating for the time of 4 seconds. Okay. And next I am calculating for the time of 8 seconds. So when I say at the time of 4 seconds, I mean calculate the displacement from when I have thrown the ball, that is t equal to 0 till 4 seconds. Calculate the distance traveled from 0 to 4 seconds. Similarly, calculate the displacement from 0 to 4 seconds. Whereas when I talk about velocity, I mean the instantaneous velocity at the moment 4 seconds, or the instantaneous velocity at the moment 8 seconds. Okay. So just start with this question, work this out. So for this question now we'll be using these equations. So first I'm just showing you these equations. Okay. Now the question is already instructing you to take the value of g not as 9.8, not as 9.8, but the approximate value of 10 meters per second square. And the initial velocity with which we are assuming we've thrown the object is 60 meters per second. So from that and making use of the equations, these are the things we have to calculate. The displacement it has done from 0 to 4 seconds or 0 to 8 seconds. The distance it has traveled from 0 to 4 or 0 to 8. And the velocity it has at the moment t equal to 4 seconds, or the velocity it has at the moment t equal to 8 seconds. So just try this out, people. We'll discuss this next. Okay, people, so I'm just checking the answers you got. Correct. Dhruv, your answer is correct about this thing. Let me check everybody's. So Aparna, the E part, 400 meters minus 20 meters per second square. Displacement. Okay, I'm not quite getting everything correct as of now. So anyway, I'll tell you what values you should be getting. Okay. So for the first part, I mean for the A part, but I'm taking t equal to 4 seconds. You should be getting the displacement from 0 to 4 seconds as this thing. 160 meters. Positive or 160 meters. Okay. And you should be getting the distance traveled also as 160 meters, but without the sign, okay, because distance is not having any direction. But it will have the same magnitude, it will be 160 meters. And you will get the velocity at t equal to 4 seconds as plus 20 meters per second, which means that it's going up. We are taking upward direction as positive. Whereas when you calculate the B part, t equal to 8 seconds, interestingly, you will get the displacement again by the formula as plus 160. Now this might confuse you how this is possible, but you'll realize that it also is coming down. No? The body also comes down. That is why, so the distance traveled, we'll keep that for the moment, but definitely it will be greater than 160 because you know that it's gone up and come down. So I'll tell you how much it is in just a moment. And the velocity, if you check with the formula, you'll see it will be exactly minus 20 meters per second, which means it has that symmetry. It's now on its way down. Okay. So the only thing I haven't given you yet is this distance, which I'll calculate and tell you. Okay. Okay, Aparna, understood. Okay. So the distance traveled, according to me, you should be getting 200 meters. Okay, I'll just verify and tell you, but it should be 200 meters. Now this is not as simple as it looks. Okay, it's a little bit tricky, so I'll explain in detail. So let's take each part and understand. Okay. So the thing is here, for displacement S, and velocity, instantaneous velocity V, okay, we can use the formula. We can just use the formula blindly without doing anything else. Okay, that if we are taking upward direction as positive, so t equal to 0, we have projected it with plus u. So at some time, t, it has a velocity v, it has a displacement s, and during this time the acceleration is minus of g because it's pointing downward. So we can use this. So we can use that formula v is equal to u minus gt, and we can use the formula s is equal to ut minus half gt square. So for these two things, we don't need to bother about anything. You just directly substitute in the formula. Okay. So for the A part, you substitute T as 4 seconds. U is of course plus 60. And G is 10 meters per second square. So you will get your velocity as plus 20 when you substitute, and you will get your displacement as plus 160 when you substitute. Similarly for your B part, so this we are getting by just substituting in this formula. We are just substituting here in this formula. And we are getting this. So you can see that for this part, your V is 60 minus 10 into 4. For this part, your S is 60 into 4 minus half into 10 into 4 square. And from that, you are getting this. Okay. Now, similarly, you substitute for the B part and you will get a different set of answers. You will get V. So for the B part, you substitute a time as 8 seconds. So when you do that substitution, you will get your V as minus 20 meters per second. So that means it has now a downward speed of 20 meters per second at t equal to 8 seconds. Okay. And it will have a displacement of, again by that formula only, it will come out to be plus 180 meters. Sorry, plus 160 meters. Okay. So I'll show you the interpretation of this also, what this means. But these are the answers that you will get by substitution. Okay. In A and B part, just substitute. Okay. So how come the displacements are coming same and the velocities are coming symmetrical? One is upwards and one is downwards. So that is why we'll understand the symmetry of vertical motion. Okay. But before that, let us just understand what we can now comment about distance travel. So now in the same thing, the other thing we can see is that distance travel. Okay. Now this distance will be equal to the magnitude of displacement if the direction does not change, or does not, you can say, reverse during the motion. Okay, so that is what is happening in the first part. But on the other hand, this distance will become magnitude of displacement, let's say S1, plus the magnitude of displacement S2, where S1 is upwards, S2 is downwards. So that is what will happen in the second part. Whereas in the first part, it will be this one. So how do we know this is happening in the second part? We know it from the direction of velocity. Okay. So if you do a comparative study of the two parts, 0 to 4 seconds, that's the first part. Usme kya ho raha hai? The body is starting, or the ball or whatever is starting initially with a velocity of 60 meters per second upwards at the time t equal to 0. Okay. Now what we are getting is that at t equal to 4 seconds, its velocity is positive only. That we have checked out from the formula. So the velocity is still plus 20 meters per second at t equal to 4 seconds. Okay. So you can see it has not turned direction. So that is why in this diagram, this quantity, which will be the displacement from here to here, will also be the distance traveled. From here to here, this will be my displacement. Okay. Now this displacement will be the same thing as, the magnitude of the displacement will be the same thing as distance. Okay. But now if you compare this with what is happening at this interval of time, 0 to 8 seconds, so you'll realize that the information that your formula is telling you, that it started with a positive upward velocity at t equal to 0 of 60 meters per second. But now it's also telling you that at t equal to 8 seconds, the velocity is how much? It is minus 20. So that means what has happened is it's actually gone up to some maximum height and come down. And then now on its way down now, it is having this downward velocity of 20 meters per second, which with sign we are writing as minus 20. So v is equal to minus 20 at 8 seconds. Okay. Now the interesting thing is that you can see that we are also getting the displacement, which is now this one, as the same as this value. We're getting this displacement from here to here as plus 160 meter. But you can also understand that, you know, this is 8 seconds. This time here is 8 seconds. But in between, what has happened? It has also gone up like this. It has just gone alongside upwards with 20 meters per second at t equal to 4 seconds. We just saw that. Then it has gone up, reached some maximum point, and then come down. Okay. So that is why now the distance traveled is not going to be 160 meters. The distance traveled is going to be the displacement from here, from the ground, till whatever highest point is reached. And then add to that the magnitude of that displacement from that highest point to this point where its velocity is again becoming minus 20 or the time is 8 seconds. Okay. So between 4 and 8 seconds, somewhere you can see that the direction is changing. So that is why in this case, the distance will not be directly magnitude of displacement. This will be displacement from 0 to maximum displacement point, highest point. And then add to that the magnitude of displacement from maximum to 8 seconds, whatever that is. Okay. So that is why that will ultimately come out to be greater than 160. It will come out to be, when I do the calculation, I'll show you it will come out to be 200 meters. Okay. But how do I know कि इसमें direction change हो गया और इसमें direction नहीं change हुआ है? Because I can see that in the sign of velocity here, it's starting with positive and here it's still positive. So the direction has not changed in between. But here it started with positive and now at 8 seconds the velocity is negative. That means somewhere between 0 and 8 it has changed direction. So that is how I understand that in the second case I cannot write the distance traveled as 160 meters. Whereas in the first case I can write the distance traveled as also 160 meters. Okay. So I'm just minimizing this for a bit of time so that you can understand the comparison of these two things. Okay. So first of all, you understand these points over here. For displacement and velocity, we can directly use these formulae. There's no problem in using the formula. But when it comes to distance, that is where one has to be careful. Okay, people, are the values clear for the distance? For the displacement and velocity? By substitution, how we are getting those velocities and displacements? Okay, people, so hope this is clear. So I'm scrolling down now to show you the representation of this with the diagram. Okay, so these are the two cases of distance. What happens if the direction does not change, then I can say distance is just magnitude of displacement. But if the direction is changing, then it is the magnitude of the upward displacement plus the magnitude of the downward displacement. So I have to separately calculate how much up it has gone and then how much down it has come, and then add those two distances. In plain language, that is how we say we are working it out. Okay. So the only thing remaining in this question is now we have to calculate that between 0 and 8 seconds, somewhere it reached a highest point and then it started descending. So wo highest point kitne height pe hai, we have to calculate that so that we can see how much height it has gone up, and then from that maximum height point, how much it has come down back to that position where it is at 160 meters from the ground. So I'll just give you a hint that that height will come out to be 180 meters. So that is why your total distance will be 180 plus 180 minus 160. So that's another 20 meters. So it will come out to be 200. Now the question is, how am I getting that height as 180? So let's try to understand how I'm going to get that. Okay. So as a hint for the distance part, I'm telling you that when you do the calculation, this is what you'll realize, that when I projected this from the ground, at a velocity of plus 60 meters per second, this would have reached some maximum height over here. Let's see. So this is its upward journey. So this is its upward journey, and let us say this maximum height is h. It's just h of h, which is this whole length from here to here. Okay. And thereafter what happens? It starts its descending part. So from here now it starts descending downwards, and on its way down, we know that at t equal to 8 seconds, it is over here. It is at a height of, or it is at a displacement of, that we already calculated just now. So we know that this thing is 160 meters. Okay. So now what about the total distance it is traveling? The total distance will just become h, whatever that h is, plus this distance here. Let's say this is some y or something. Okay, so it will be h plus y, which is basically nothing but h plus h minus 160. Okay, so I already know this 160. So it's only a question of now I have to find how much h is. Okay, so the whole question now comes down to how I'll find the value of h. Okay, now the hint for you is, see, on the way of ascent, while it is going up, kya ho raha hai? It's decelerating, and on its way down, again the speed is increasing, it's accelerating. So when it reaches the highest point, it has a particular feature of its motion. And what is that feature? That it's at rest momentarily. What happens at the highest point? The velocity is how much? 0. Okay. At the displacement equal to the maximum height, at the displacement equal to the maximum height, what happens is momentarily the velocity becomes 0. So I can make use of that to find out how much the maximum height is. Okay. So this is an important point here, that wherever it reaches the maximum height, at the highest point of its motion, the instantaneous velocity is 0 and the displacement is h, which is the maximum height. So make use of that and try to prove what I said earlier, that you will get that height h as 180 meters, and that's why the total distance you'll get is that it's gone from 0 to 180 and then it's come back from 180 to 160. So it's come down another 20 meters. So it's traveled a total distance of how much? 200 meters. So now think how you can calculate that h from the equations that we have derived. Okay, the answer lies in the equations only. Okay, and this fact that at the highest point the velocity is how much? 0. I can see somebody's got the answer. Yes, 180. Correct, beta. You got it right. So which equation you used for that? Aparna, can you just tell me which equation you used, the first, second, or the third? Yes, time is 6 seconds. So you probably use the first and second equation, right? Okay. Yeah, you can directly use the third equation. Then you won't even need to calculate the time when it reaches the highest point. So that's it. So you can use the third equation also. So this you want to find out how much this height is. So for that you use the third equation of motion. So you also have, apart from v is equal to u minus gt and s is equal to ut minus half gt square, you also have v square is equal to u square minus 2gs. So because we'll substitute a as minus g. So in this equation, what you do is you substitute v as 0 to find out the displacement value, which is the maximum height h. So from that you can see you get a nice formula for maximum height. You get a formula that h is actually equal to u square by 2g, or in this case it becomes 60 square divided by 2 into 10. So that's 180 meters. Okay. So this is a little trick that we use to find the maximum height. The fact that its velocity is 0 at the maximum height. So this is our equation 1. This is our equation 2. And this is our equation 3. Okay. Now you can also see from equation 1 that at the highest point, the time will be how much? It will be u by g, or 6 seconds in this case. Because again, put v as 0 in the first equation. So that will tell you what is the time when it reaches the maximum height. So now from this we are also understanding that 0 to 6 seconds, it's ascending, and then 6 to whatever further time. Okay. So here of course I am concerned about 8 seconds. So at 8 seconds it's coming down. So that's why the total distance traveled, okay, we can write as h plus the magnitude of displacement from 6 to 8 seconds. Okay. So this is this thing, it's 180, whereas the displacement from here to here is how much? It is actually 160 minus 180. So that displacement is minus 20, but it will come with a mod sign. So it will be plus of mod of minus 20. So it's going to be 200 meters. Okay. So this will be the total distance traveled. For a projectile thrown at an angle of 45 meters, then we have to take the components of the velocity. So we have to. So if you throw a projectile at Dhruv, to answer your question, if you take a projectile of speed u, okay, at an angle of let's say 45 degrees, then this speed's vertical component, that becomes how much? It becomes u by root 2. It becomes u sine 45. So the maximum height, instead of u square by 2g, it actually becomes u square sine square theta by 2g. We will be coming to that in a couple of weeks time. Projectile motion we'll see. So we just replace the u of the vertical motion with the vertical component, which becomes u sine theta. So that's why the formula, if you see in some standard book and all that, for the maximum height of the projectile, the formula is u square sine square theta by 2g. Whereas here, what is the formula we got for the maximum height? We got u square by 2g. तो यहाँ पे जो u है उसको हम किससे replace कर देते हैं? Vertical component of velocity से replace करते हैं, which is u sin theta. But you know we have to learn few more things before we come to that, okay? Including components of a vector and things like that. So I'll be coming step by step to these things. Okay. So this is where I'll conclude this lecture. So we have seen the important equations of displacement and velocity, and the third equation, the relation of velocity and displacement with respect to each other instead of with respect to time for a vertically projected object. Okay, which are those three equations which I wrote earlier. These ones. Okay. V equal to u minus gt and ut minus half gt square. These ones. So these, remember, are applicable for these quantities: velocity, displacement, and velocity in terms of displacement. But whenever we are calculating the distance traveled in a vertically projected object, okay, whenever we are calculating the distance traveled in a vertically projected object, at that point of time, basically what we have to do is we have to be mindful of this thing, that is the direction of the motion changing in between. If it is changing in between, then we have to break the motion into two parts like we've done over here, going up and then coming down. Whereas if it's only going up, then we can calculate the distance directly as the magnitude of the displacement. So this is something that we have to be mindful of. Okay. So I'd like you people to review this question carefully when you're revising these vertical motion equations today. And if you can also try and solve this yourself by graph method. Okay. So solve for displacement and distance using the V versus T graph instead. Okay. Alternatively, instead of using the formulae and so much calculation, see if you can just, for this particular question, take the initial velocity as plus 60, the acceleration as minus 10, and draw the graph of velocity versus time, and see whether you can make use of the graph and graph concepts we discussed till date to find directly the distance and displacement. Okay, so that will give you some additional practice on how to do this question by graph method instead of by relying on the formulae and then finding maximum height and things like that. Okay, so people, that's it where we finish today. So I will give you a small worksheet of problems which will basically have vertical motion type of problems and maybe one or two graph type of problems also. And next time we will do more about vertical motion with these type of situations. We'll see vertical motion where instead of throwing something from the ground, you're dropping something from a building, or from a certain height, you are actually throwing something vertically downwards. So there what happens, from the word go, it's accelerating towards the ground. It doesn't first go up decelerating and then come down accelerating. It actually, you're throwing it straight down. So it accelerates from the word go from the time you throw it. So we'll see those type of situations also. And time being, if I take the time in the next lecture, I will also start with the introduction of relative motion. Otherwise, that will be the next lecture after that. All right. So that's it for today, guys. Hope you people have understood most of these things and especially understood the questions in the test and all that. And I will be the answer key of the paper along with the solutions that we've discussed today. So if after that also, if you have any confusion or anything to ask in any questions, you can always directly WhatsApp me. I will help you out with that. Okay. So that's it for today, people. God bless and stay safe and also keep studying. All right. That's it. Bye, people.